Okay, so we're continuing on talking about increasing and decreasing functions. And we've got another graph here. It's continuous this time, but it is obviously defined in pieces, so it's a piecewise function. So we're going to look at, hey, where are we increasing? And so I'm going to use the highlighter this time. So we can see as we go left to right on our function, it's increasing on this segment and also here, right? So we're going to eyeball those. So our x interval on there, negative infinity till, we can eyeball that. Negative 2.6, negative 2.7. As long as you're in the ballpark on something like this, if it's not labeled, it's okay. And then this one here, maybe about 1.5 up to 4. And again, these are all open intervals, so no brackets, just parentheses for increasing, decreasing, and constant. Now decreasing, we are looking at just this segment in the middle, right? So make sure you're using the same points as you did before, right? Because this kind of picks up, it's increasing, then, oh, we're decreasing. So we're looking at negative 2.7 to 1.5 for our interval. And then where is it constant? We'll highlight that one in green, sure. We're constant right over there, and we're going off to infinity. So we'll say 4 to infinity. And it's an open interval, so parentheses. All right, what's our domain? Well, there's no discontinuities here. There's no x values where the function does not exist. So it's another all real numbers. And our range, we start here, we start at the bottom, negative infinity. We have a function. And we're going to go up all the way until our highest value looks like it is 4. That one is included. That gets a bracket. All right, so I think the last thing in this chapter is relative and absolute maxes and mins. So we'll talk about relative maxes and mins first, or sometimes called extrema. So a relative max or peak occurs at a value of, say, x equals a, and has a maximum value if f of a is greater than f of x when x is near a. So in other words, we're trying to look at, like, if our function does this value here, this x value, that f of x is bigger, sorry, that should be, we'll call it a. We'll call it a to match up with what I just said. That a value, that f of a value, is higher than the surrounding, the close by values f of x. Okay? Same story with a minimum, right? Anywhere where the function has a relative minimum value, so we would have something here, right? So we've got an x equals a, and that f of a value is lower, is less than, so we should say b here. The f of b value is lower than any of the surrounding values, less than any of the surrounding values. Graphing can really help you locate these points because we don't have calculus yet, so we can't find them exactly with just algebra. But if you go on to calculus, you'll be able to do that. But I'll show you the extremum tool in just a minute or 3. So here's a visual on your relative maxes and minimums, right? So we've got two relative mins, the one here and the one here. And assuming that this function, that we're showing all the interesting parts of this function, that this part is also an absolute min, because it is the lowest minimum, there we go. It is the lowest point on the graph anywhere. There is no absolute max on here because our graph keeps going up and up and up and up. All right, so we're at the 5-minute mark. We'll take a break and try to wrap this up in the next segment.